Well, you have one of these old drills, a 9 or 9.6 like this one, and, well, the battery just can't hold a charge anymore. Do you remember the other day when I showed you how to make it electric? Well, today we're going to give it a second life, but this time making it portable, using 18650 batteries recovered from a laptop battery. Perfect. We're going to switch from the old nickel-cadmium batteries, which are these, to the powerful lithium ones. The charge is going to last you much longer, and in this case, you'll have the screwdriver, which is 9.6 volts. I'm going to give it a little more voltage, and I'll also have more power in the screwdriver. We will use 6 Samsung 22E cells organized in 3 packs of 2. A battery management system which you can buy, it's not expensive, it's 3 outputs, 40 amps. And, well, I'm going to show you how to check if the recovered batteries are actually good for this job. Not all 18650 batteries are the same. These ones, which I recovered from that old battery pack from an Hewlett-Packard, are the 22E. They're low discharge, 4.4 amperes. For a drill, it would be ideal to use high discharge cells, like the Samsung 25R or Sony BTC5, which provide 20 amperes or more. But anyway, we're going to do a little trick so we can use them. Since I only have these, nothing else, I don't have others. I mean, I have some other recovered ones, but they're pretty bad. And, well, these are good. The solution is to connect them in parallel by joining 2 batteries. From these, we're going to add up the current capacity. It'll be 4.4 plus 0.4, which almost gives us 9 amps, which is enough for a drill for a screwdriver, let's say, a regular one for home use. My drill is 9.6. If I use only 2 cells in series, that is 2 packs of 2 cells each in series, I'll have 7.4 volts. It will have little power. By using 3 packs in series, we get 10.8 nominal volts and 12.6 volts at full charge. This small overvoltage will give the drill a power that, well, it didn't have before, right? And without burning out the motor. In general, motors are quite forgiving, quite tolerant, and those couple of extra volts won't damage or overheat it. We'll use a 3-output voltage monitoring system, 40 amps. Is this the one? Why are we using 40 amps if my batteries are 9? Well, because the voltage monitoring system needs to handle the startup peaks of the motor, which are sometimes much higher than 9 amps, so it doesn't cut off, that the battery gives you. If you recover laptop batteries, try not to remove the nickel strips that are spot welded to them. Just like they are here, I didn't desolder them. And that's much better than soldering the wire directly onto the battery. Because, well, the battery can get damaged by the heat from the soldering iron. It can damage the internal chemistry of the battery. I've soldered it many times, but, you know, you should try not to solder directly on the battery terminal. Well, here I have the 3 packs, and we're going to connect these packs in series. In this image, you can see how they should be connected to the battery management system. There are 3 packs of 2 18650 batteries. In parallel to the negative of the set, that is, once they're already connected in series, you connect it to where it says 0 volts on the battery management system. The positive of this pack, which we connected to the negative, will be connected to where it says 4.2. The positive of the next pack goes to where it says 8.4 volts, and the positive of the last pack goes to where it says 12.6. Here, you can see it clearly. I've made it for you in this image, so there's no confusion. The battery management system has an output that's marked with positive and negative. That output goes to the power supply of the screwdriver or drill or whatever you're going to power with that pack. And also, that same output is used to charge the batteries. You supply 12.6 volts there to charge. Let's say these battery management system are type I. You use the same output to also supply voltage to the batteries so they can recharge. And how do you know if these recovered batteries are in good condition? All right, let's connect the 12-volt charger. I've already assembled everything with the 3 packs, each one with 2 batteries. We put them here to charge. We keep an eye on the packs while they're charging. If you see that one of the packs charges immediately and quickly reaches 4.2 volts, it's because that pack is messed up, it's worn out, you'll have to replace that pack. Another interesting test, so you don't have to measure all the time, is that once you've charged it to 100%, you leave the battery without charging for 24 hours. And then you measure each pack separately again. If there's one that dropped more than it should, that doesn't have more than 4 volts, 3.9, 3.8, and all the others have 4 and something, well, that pack definitely has a leak. I'm actually doing that test right now. Yesterday, I charged the batteries, and you can see that when I measure the central pack, it reads 3.4, 3.5 volts, while the other 2 stayed at 4.2. That pack is definitely messed up because there's a reason they changed that laptop battery. One or both of those batteries are bad, so I'm going to swap out that pack for some twins I have here. One is an LG S3, which is practically the same as the others. And I also have a Sanyo UR 18650A. Well, this one has a little less capacity, but let's use these that are more or less in good condition. While I run the test to see which of the other 2 are dead, or if both of them are dead, you have to remember that these batteries, well, they're from a laptop. They work great for the screwdriver. But if you're going to drill concrete for 10 minutes with a drill and these batteries, well, they're going to get hot. You have to be smart about how you use them. Also, don't use a 10mm hole saw, or if it's a screwdriver, like in my case, I'm not going to try, I don't know what, to take apart a tractor wheel with a socket, because obviously it's going to get hot. It's for use at home, for putting in small screws and, well, all that. I mean, you have to use it, let's say, intelligently. We've gone from a dead drill to a powerful tool with a lot of autonomy. You have several hours of autonomy. If before, with the original battery, I could screw in about 50 screws now. With these batteries, you'll be able to screw in 100. A warning before finishing: lithium is not a toy. Always use a battery management system. Don't make direct shorts on the battery or charge it directly. And make sure nothing causes a short circuit inside the case. In my case, the 6 batteries and the battery management system fit in very well. It's also important to use thick cables and for charging the pack. The old 9V charger won't work for us anymore. We'll need a 12V one, preferably a 12.6V. Or you can adjust it to that voltage. I have this one, which was from a DIRECTV decoder, so it worked perfectly for recharging the batteries. And the screwdriver turned out really powerful. Check how it works if you have doubts about how to connect your battery management system. Even though I already showed you the little board and how it's done, let me know in the comments, leave your like, and subscribe for more epic recoveries. Hit the bell to get notifications when I upload new content. You can also join, and in that case, I'll add you to a WhatsApp group where the premium members are. Thank you so much for watching the video, and until next time, God willing.